So resampling. So this is a method we can use for time series. And basically this allows us to find like a particular, what's it called? Like if there's a particular like frequency in the pattern. So for example, if you have like this long period of information that repeats over per month, or repeats over per week, or repeats over even year. For example, if you're looking at multiple decades, maybe you want to see this difference. You can actually use downsampling and upsampling, okay? And so our downsampling, basically, it resamples at a lower rate. You might lose some information. It's more computationally efficient. So this can actually be useful, like if you want to have less information, like there's a lot of data. This can be like, oh, we just want to do some quick test, or we don't need all the information here. Like we don't need every single detail. So for example, if all you care about is the change of temperature over a year, right? You don't necessarily need to know every single hour of the day. And so in a lot of ways, is like if you put in the temperature of the day for every single hour over a year, first of all, you're gonna have a lot of data, right? So like, hey, let's get rid of some of that data because some of it's kind of redundant, okay? And two, is that it might actually obfuscate like what you're seeing. Like the temperature throughout the day, as you can probably guess, at night it gets cooler, and in the day it tends to get hotter. So you'll see this pattern over and over again. Like that doesn't give us any useful information because that's true every single day. So let's kind of basically downsample and make it just about the day itself, or maybe even up to like the week or the month. Okay, so I have an example here. So right here I have, let's see here, our DF temp, and our DF temp was, I believe, I remember exactly off the top of my head. Yes, our DF temp, oh, I was thinking temporary, this is our temperature, right? So our DF temp basically had something where it's like every single day, right? Which again, can be really like kind of interesting, but is it necessary for our full view? No, we might just need one just every single, what's it called? Our month, for example. So in this case, we just average out using this free sample. And this is where different, if you wanna look at this specifically, you would look at this function here and say, what can we use? For example, what the rule is. This rule in this case, we're actually doing that mean samples, or doing a means. And so basically we're just gonna do a average of that month and condense it into one part. So you can see here, instead of having 365 days, I now only have 12 different data points. And this might be useful if you're looking at just this, like for example, for this year. Okay, and you can see if I did a bigger head, if I did something like, let's do 20. So you can see that it does this for multiple years, right, as it keeps going through. And just to kind of show you a little bit what the original one looked like. Oh, I don't have it right. Never mind. Oh, DF temp, that's what it is. Okay, so you can see here, this is our original data. So you can imagine every single day, we might not want every single day. And this might be really true for if there was an hour, like we would definitely not want it every single hour. So.
Wait, sorry, would a method of resampling then, so like if you're thinking about temperature, since it's also following a daily cycle, would there be a method where you could like take the data point from, if you had the hourly data from like certain hours throughout the day, and so instead of like having 7, 8, 9, 10, 11, you just take like 9 and 12 and like on 3-hour intervals? Would that be a method of doing it?
Yeah, that's right. And that would be a different frequency. And this is where this
rule?
Yeah, that rule, like you can see this guy right here. You could look and say what specific, like obviously MS, like what is that? That's specific to this function. And what is it? And so that's where definitely, like, you know, if you're like, hey, like let's do a frequency instead of like, let's say you had hourly data. Like at first you did like, you know, every day, and like, well, you know what? I actually want to see the pattern, I don't know, for whatever reason, change over like, you know, a 3-hour period. Like that could be something that's useful.
Okay.
And you put that in here. Okay. And main idea of downsampling is that you're basically just like taking the points from your overall data to make it smaller. And hopefully you're actually, like the real reason why you're doing that is one could just be making it more computationally efficient. Like if it has every single hour, maybe you only care about the day, but also it could be you're trying to find that period and something like that. Okay. So this leads us to upsampling. But before I move on, any other questions about downsampling? Cool. And hopefully that's pretty clear. It's like, oh yeah, we're just going to basically pull out the information. So we're condensing the information to summarize the more detailed. And again, that's what makes it more computationally efficient. Upsampling is kind of the opposite. Instead, we basically resample at a higher rate. So this is in the case like we want to actually keep our information in here. So we're not losing any information. In fact, we're kind of gaining extra information. So for example, let's say you have data that, the reason why you might want to do this, like you have two different data sets. So like, let's say you have this data set originally with this DF temp, and you can see here, it's like, oh, it's by day, right? But our other data sample, or our data we collected, it's going, every, 12 hours. It's like, well, I want to be able to merge this together, but I don't have that information on here. So we can upsample essentially, and create, it's like, well, let's just pretend that we have this extra information. So in this case, I actually can combine this together and say, okay, now let me just go ahead and say, oh, this is going to be at 12 a.m. This is going to be 12 p.m. And you can adjust this, in the settings, like, well, what exactly time it should be. But the point is basically you can create now something that happens every 12 hours. And in this case, by default, you can see here, since I don't have this value, it just says it as 0. But we can actually change it and interpolate, right? And fill it in. So you can see here, it's like, well, in this case, I'm just going to fill in all the unknowns. In this case, I'm just repeating the data over and over again. So this might make more sense if you're doing something where, like, again, you have all this data and you just want to combine them together easily, put it together. This is probably not the best example because our 20.7, if we actually had a real world data set that happens every 12 hours at 12 o'clock a.m. and 12 o'clock p.m., you probably would have different temperatures each time. And that might be an important aspect that you want to make sure you combine properly. So this is not the perfect example of when you would do that, but you could technically. Or at the very least, you could say, well, okay, this data minimum, it's probably about 12 o'clock. I'm just going to go ahead and put this down as 12 midnight kind of deal and say that's our data point. And then I just don't know what the 12 p.m. Point is. Okay. And then here you can just see, instead of doing 12-hour fills, I do it for every hour. So you can see here as I put this through. And this is really useful if you want to combine data all together with another data set that has a different kind of frequency. Okay. Any questions?